Hello everyone. So I'm going to talk about observability in Swarm and how we approach this with the services that we operate for our users, namely the Swarm gateways that Danny said that you shouldn't use, and I would like to double on that. So if you really want secure access to Swarm, you should be running your own Swarm nodes. And hopefully this will also help you understand what your Swarm node is doing once you actually run it on your own system. So a bit of history of Swarm from a perspective of a developer and someone who's been new to Swarm. So I joined the team in October 2017, so 1 year. And at the time, basically, what was the state of the code base is that we had no canonical master branch. There were multiple feature branches, mostly conflicting with one another. The Swarm Gateways was running POC2, but it wasn't really clear which commit or which version that is. And we had no canonical Git repository. So we had Ethersphere, there was also Ethereum, but POC2 was actually on a specific commit in the Ethersphere repository. So it was a bit difficult to understand which code is running on the gateway and what actually is happening within this node. So basically it was a black box that you had to restart every now and then, and you didn't really have much visibility over what's happening. So you would hit the gateway, you can upload content, you can download it, but every now and then it would get really slow or you wouldn't really know what's happening. So we were basically wondering how to fix that. And the plan that we came up with, obviously to consolidate all the feature branches and merge them into a canonical one so that we have continuous integration of the code base. Also, point 2, to increase the visibility. We then decided to obviously introduce a release process, which we now have. So now you can get a new Swarm version every 2 weeks, and you pretty much know that if something is broken that used to work fine, you know that basically a problem has been introduced into the code base over the last 2 weeks. It's not difficult to find what's happened because of the small amount of changes. And the last one was to basically simplify deployment so that our users know what version the majority of the nodes in the network are running. Obviously, we are not the only ones who are running Swarm. Swarm Gateways is just a subset of the nodes of the network. But as a new user to Swarm, that's probably the place that you're going to go if you want to try Swarm. That's the lowest barrier of entry right now. So what I'm going to talk about in this talk is mostly about how do we increase visibility, how do we know what's happening in the Swarm node when we run one. So observability can be defined as basically those 3 pillars: aggregation of logs, aggregation of metrics and statistics, and distributed tracing. So there is a really nice blog post on how Twitter approached that, and you can read it. They basically explain how they went from a monolith to a distributed environment, and basically the challenges that came up with that. With Swarm, we've always been in a distributed environment, so that's pretty much applicable right from the start for us. I mean, you need to understand how your requests go from one node to another and basically make sense of all the protocols that are running. So there is another really nice blog post from Peter Borgon, who basically has this nice diagram on what he understands in terms of observability. So we have metrics that are aggregate statistics that all nodes emit, and we want to basically aggregate them and get a full view based on all distributed processes. We also have tracing, which is pretty much request scoped. So let's say that you upload something to Swarm, or you try to get something from Swarm. You're interested in your specific request to the network. And also logging is similar to tracing, but in terms of events. So for logs, we are using the Go Ethereum log package, which is pretty much a modification of this other library. It's a structured logging library for Go, nothing complicated there. It was already part of the code base. it was just that we were getting logs only on the standard out. So we were thinking of a way to aggregate the logs from all the machines so that we have one common view and easy access to our logs. So that's pretty clear. There is an example of how you would do it within the Go Ethereum code base, and yeah, Swarm is part of that. What we introduced was the request unique identifier, also known as a correlation ID. That's something that you could use if you build on top of Swarm in terms of features within Swarm. So what this is basically we generate a correlation ID for requests that go into Swarm, and then we store it in the context. From there on, you basically can propagate it to any of the internal subsystems, and you know that a given log basically belongs to a specific request. And how we use that is, this is just a simple screenshot of one of the systems we use. We basically search for a specific request identifier, and then we can see the whole path of the request within our network. It's helpful for debugging, and let's say you run your own Swarm node and you're wondering why you're getting results that you don't expect. That would be the first thing to check, basically your unique identifier and where your request has gone through within the code base. So what do we log? We log obviously errors, and when I say errors, I mean something that a developer must look at. That's the definition that we use. We also log warnings, something that might happen, but it's not necessarily an error. Let's say a high number of some warning might be suspicious and something that we should investigate, but a single warning is probably not something worth spending time on. We also log a lot of request and response specific information. But still, I want to emphasize on the errors. Everything that comes out as an error, it's something that we should be looking at and trying to get out of the code base. That's probably something that's a bug. For aggregation, we used to use OKLog, and it's a very simple log management solution. We just deploy it within our cluster, and we aggregate all the logs that we receive from the different nodes, and that's how it looks like. I mean, you can pretty much just search and run different queries towards the system. So for metrics, we are using the Go metrics library. Again, it's part of the code base. It's a fork of the famous Codaheo metrics library. Some of you probably come from a Java background or not, but it's a really popular Java metrics library. So the way to instrument the code with it is basically just create, let's say, a counter and increment it, or that's an example of how you can measure latency. You basically record the time, you set your timer, and at the end you update it when the event you try to measure has finished. It's quite simple. So with metrics, basically they help us detect issues within current and new versions of Swarm, and they also show us the performance of our nodes. So it's a very handy tool when you deploy a new version to basically compare the metrics that you got up until that point and after the deployment, so that you see if you have introduced regressions or you see if you have improved bugs that you have had in the past. So that's something that we're heavily using. So what do we measure with the metrics? Obviously infrastructure metrics, that's clear, memory usage, CPU, disk usage, and most importantly the application metrics. So that's the errors that I talked about, warnings, different info counters. We also measure application specific things like number of peers per node and all the different message exchanges between peers. So that's where the interesting information comes along. It basically helps you visualize what a specific node is given in doing it at a given time with respect to the different protocols that it's running. In Swarm, that would be the BZZ protocol, the stream protocol, PSS, or anything else. So this is what it looks like within the dashboards. It's not very visible right now here, but it's basically 4 dashboards, and those things that you see here, these are the different nodes that we're running. So it's a handy way to basically visualize all the errors on a set of nodes and create alerts for them and monitor a large deployment of your network. In, let's say, a developer's use case, that would be only one node, let's say your local node, and you can visualize what your local node state is at given time. That's again the infrastructure load, and that's an example of application monitoring. So we also run this when we are doing simulation tests, and that specific screenshot is from a run on the PSS simulation tests. At the time we were comparing different transport models, and you could see that at some point the metrics become flat. And on the right side, we're basically measuring the number of calls to specific PSS handlers. So it pretty much looks clear that at some point we just flat out and we're not incrementing the counters anymore, which tells you that your process is not doing anything at that point. And this might be expected or unexpected, depending on the simulation that you're running. It basically gives you visibility over your system. And the last one is the distributed tracing. That's the system that we introduced within the Swarm team. So we decided to use open tracing. Open tracing is basically vendor-neutral APIs and instrumentation libraries. They have standardized the semantics of what they mean by span, trace, etc. There are different client libraries. We're using the Go library, and there are popular tracer supports. So basically those systems that actually aggregate the traces from your processes and produce a nice visualization so that you can make sense of your traces. So I'll go quickly through the open tracing data model. Basically, traces are defined implicitly by their spans, and a trace can be thought of as a DAG of spans. So this is what it looks like. You have one root span, and then you have a lot of children of that span. So let's say that your request comes into the system, you create your root span, and then within the internal subsystems of your process, you just attach spans to the parent root span. So that's how the relationships between spans look like in a single trace. It's also useful to think of it within the temporal space. So generally the root span is going to have the full length of a request, whereas its child spans are gonna finish within the root span unless you fire up asynchronous jobs from, let's say, your root request. So that's the data model of the open tracing model. And how do we use this in Swarm? We basically have instrumented our code, and this is a screenshot of an HTTP GET request for a specific root chunk. So basically you can see the full length of the request and the internal systems that it's doing. I'm not sure that's visible for you, but basically the root span is the HTTP GET file. Then we can see that we're hitting the API package, and we see that then we go into the chunk reader, which is responsible for fetching the individual chunks that the root hash is built of. Here is another example where we actually issue an HTTP GET request to a specific Swarm node, and we trace it within our network of hosts. So we can see which other nodes specific request is hitting. So let's say that you don't have all the chunks cached on your local node. You can visualize which other nodes you are hitting in order to retrieve the chunks for that specific content. Obviously that is taking privacy out of the window, but it's there for debug purposes. We don't expect people to be running this in production. And even if they are, obviously this is just giving you information on the nodes that you control, and you're pretty much free to do whatever you want with your nodes. That's something that you should have in mind, that when you are using a public gateway, you might actually be losing, your privacy. So you should be running your own nodes. How does that work in terms of Go? Adding the instrumentation. It's just a simple example here. We have a handler function for one of the protocol messages. In this case, it's called offered hashes message. And when we handle that message, the only thing that we do is we define this span, and we also extract the root span from the context. So we're basically attaching the handle offered hashes span to the root span, which is kept into the context. And the context is propagated within all the internal subsystems so that you have access to this instrumentation. That's how you get the relationships between the different nodes. So how do you use all that if you're a developer and you want to develop on Swarm? Basically, the simplest way to do the tracing is to run the so-called aggregator, and with open tracing you can run, for example, Jaeger or any other like Capdash, etc. With this simple Docker command, you can start it on your local machine, and then you just have to start Swarm with tracing enabled. That's the tracing flag. You need to give the endpoint, which in this case is localhost and the 6831 port, and you also have to give your node a name. In this case, my local swarm. With metrics, we developed a tool that bundles together InfluxDB and Grafana. This is basically the stack that we are using for metrics and where those charts are taken from. So the way to do it is you can use the Status tool, which pretty much downloads InfluxDB and Grafana. You run it, and that starts a local InfluxDB and Grafana instances on your machine, and then you just have to start Swarm with metrics enabled, as well as the export enabled. So metrics are aggregated within the process, and then every few seconds they are emitted to this central repository, in this case InfluxDB. So that's pretty much all I have for you today. So. Any questions? Victor? So the question is there any visualization that is better than the tracing, and if there is something in the works? No, I'm not aware of such a tool. So tracing together with the stats, that's how you get visibility over your systems. Anything that adds more value to it, if something in the audience knows, I'd be very interested in hearing about it. But that's the state of the art as far as I know at the moment. Well, you could use, as you said, the D3 library and have simulations on top of Swarm where you can track individual events. But for anything that gets more complicated, like a request that hits 10, 15 nodes, it gets difficult to visualize that in a meaningful way.
All right, so thank you, Anton.